Okay, we're going to get this started, Jim. Welcome.
All right.
Welcome everybody to an NFPA 70E question and answer discussion with Mr. Jim Dollard and myself. And just for all of you out there on WebEx, I will have you know that we have you all on mute. Please leverage the chat. I don't have to mute the YouTubers and the Facebook people. They, I believe, know how to use the chat sessions out there. For my WebEx people, please use the chat to ask any questions while we're going through this program. I'm going to keep monitor of that, and we will make that happen. So we have myself. I'm Tom Dimitrovich, and I'm with Eaton and Vice President of Technical Sales on various committees. And with me, and most of the people, Jim, that are out here have been dialing in on these sessions that I've been doing for a while, and I really appreciate you being here. And why don't you just give a little bit of your background? I'd really appreciate it. I think everybody out there would appreciate that as well.
I sure will. Thanks, everybody, for tuning in. My name is Jim Dollard. I'm the Retired Safety Coordinator from IBEW Local 98 in Philadelphia. I've been on NFPA technical committees since 1996. A past member of Code Making Panel 15, a past member of the NEC Correlating Committee, present member of Code Making Panel 10 and Code Making Panel 13. I'm also a longtime member of the NFPA 70E Committee, a member of the UL Electrical Council, and a Master OSHA 500 instructor. So with a very practical background and experience in installation codes and standards, work practices, and product standards, it puts Tom and I in a unique position to be there as these rules are made and as they're modified. And we're very happy to share any insight we can with you.
Excellent. Okay. Let's get into, let's see, and we are speaking on behalf of ourselves, not on behalf of NFPA or any of these committees that we are members of and engaged with. So I just want to make sure we cover that as well. So this is our opinions and our opinions only. We've got a lot of good questions. I took all those questions and I put them into a PowerPoint slide for everybody. So we're going to go through one by one, have a dialogue. Please use your chat if you have questions as we go through these, answering these, and if you have additional questions, do that. I'll record those, and then Jim, maybe you and I can make a call on if we want to field any just off the cuff type of stuff when it's appropriate to do that. All right, so here we go. You ready?
Yes, sir.
There we go. First question. Who enforces facilities having arc flash labels?
We did receive, what did we get, like around 20 questions, something like that, 22 questions?
22 questions.
And there was a few in there that were NEC related, and we're really not going to have the time to get to those today because this is all about NFPA 70E, electrical safe work practices. And we moved this one right up to the front because while this is a very basic question, it is something that is confused quite often in the field. NFPA 70E is a standard, and standards, by their very nature and description in the NFPA process, are built to be incorporated into a code or a regulation, such as an OSHA regulation. But standing alone, they are not a code. One of the things that we look at is 70E and NFPA 70, the National Electrical Code. And there's a very clear line of demarcation between them. Installation requirements go into NFPA 70, the National Electrical Code. Anything that is electrically safe work practices related, it goes into NFPA 70E. And for that reason, a few cycles back, all of the installation requirements that were in 70E, because at one point it was like a cliff notes for the NEC, they were all removed. But people often ask, who enforces 70E? Who enforces arc flash labels? And there has been a lot of confusion. The fact that we've got labeling requirements in NFPA 70E, I have been involved in many scenarios where an engineer or an owner that had a new building erected, when they're doing the punch list, they say to the electrical contractor, you got to put the labels. We want incident energy and the working distance. That is not a requirement in the National Electrical Code, which means it's not enforceable by the electrical inspector. And it is not a requirement of federal regulation, OSHA standards. Everything that we're doing here today and the existence of NFPA 70E is based upon OSHA. OSHA is federal regulation. It is not best practices. So what Tom and I like to say, and Palmer and Mike Johnston and others, is that OSHA is the shall. 70E shows you how. So where OSHA has rules, for example, to protect people from shock, to protect people from arc flash, that is federal regulation. So you could actually say that it is the law. Employers have to comply with that law. The problem is that OSHA is primarily performance-based. So they give you the end goal. They tell you what they want you to get done. They want you to protect people, but they don't show you how. They tell you that you shall, but they don't tell you how. So getting back to who is going to enforce arc flash labeling, well, when you get in to 130.5H, what you will see, the very last paragraph says that the owner is responsible for the label. So if the owner chooses to install NFPA 70E type labels, they can. If they choose not to, they don't have to. The reason is it's not a requirement in federal regulation. There's no federal regulation backing that up. And Tom, you and I were discussing this morning, 70E, but when it comes to enforcing 70E, OSHA is not going to come into your facility and enforce 70E. If OSHA does come in, it's likely because there's a problem, and they will cite their own regulation. The entity that has to enforce 70E is the same entity that embraces it. And 70E, if getting it done right doesn't work, starting at the top and working your way down, or starting at the bottom and working your way up. It has to work both ways. Everybody has to play a role, which means training across the board, right, Tom?
Yeah. So I've had some electrical inspectors ask me about some of the requirements from the marking requirements of 70E, because and what I think blurred that line a little bit is the marking requirement in the NEC for service entrance equipment for 11016, right? Where
Yes.
they're saying you have to put the arc flash label and the hazard warning and whatnot. And I think what people do is what some inspectors make the error in is that they want to extend that into all of the other areas in a plant or a power distribution system. We enforce that at the service entrance equipment where it's required, but not everywhere else. So.
Yeah, absolutely. And, that's a very interesting requirement when you get into 110.16B in the National Electrical Code, because, there we tell you for services, what we tell you is that you have to label with clearing time and fault term.
Yeah.
And we've had many people say, well, why didn't you just say incident energy and the working distance? Why didn't you just say arc flash PPE categories? In the NEC, we can't. That's outside of the purview of the NEC. You cross that line of demarcation, now you're in 70E.
Yeah.
So 110.16B is probably the best example that I can think of a rule in the NEC where nobody follows the general requirement. They all follow the exception, and the exception says you don't need to label in accordance with the positive text if you label in accordance with a recognized industry standard, and there's an informational note that refers to 78.
Yep. Awesome. All right. Anything else on this one?
I think we're good. I don't see anything in the chat box that.
Oh wait, I have one here. Hold on. Let's go back. Mauricio asks. Must be immediate. Well, that's not related to this one. We are going to cover. He was asking a question about: do you think that with the new version of IEEE 1584, the labels must be updated immediately, and that is one of our other questions. We'll get to that one. Another question came in. I don't know if it's not necessarily related to this either, but what would be the ramification? What would be the ramifications if someone who overtly lies on a work permit? I can put that on the list. We can answer that later. So that's
yeah, that's most certainly a problem. And I do see a question. It says NFPA 70 arc flash labels are specifically looked for and required. That would be the generic label. The generic label in 110.16a
yes.
requires all panel boards, switchboards, motor control centers, etc., anything other than dwelling units. It has to be marked with a general warning label. And that's all it is a warning label. It says arc flash hazard. But there is no requirement. There is no general requirement in the NEC that you label in a manner like we do with 70E. The only time you get there is service equipment at 1200 amps. Now you're into 110.16b. I personally plan to submit a public input to have Code Making Panel 1 take a look at 1200 amps across the board. If we're doing it at services, then we could do it. We could most certainly do it downstream at that level.
Yeah, gotcha. All right. All right, so let's move on to the next question, which is concerning labeling requirements. So that previous discussion moved us right into to answering this question. Is the NEC going to require 70E labeling in the future?
Yeah, this is a question for everybody that uses the NEC. This is a question for every organization that is involved in the NEC revision process. Do we want to go there? Personally, I'm all about safety. I've worked more than half of my career in safety. I would love to see that happen. But it has to be incremental. It has to be incremental. And if we had everybody here in a room and it would be easy to see, I would ask you to raise your hand and say, raise your hand if you've ever submitted a public input or a public comment or a proposal and comment, as we did in the past, to change the NEC or to change NFPA 70E. And we need you to get involved. If you want to see those things happen, we get the best information from you. So my personal opinion is yes, it should be expanded in the National Electrical Code. I think that it would have to be done incrementally, and it has to be a consensus process. And my personal opinion again is that once we begin to see that type of labeling with all of our feeders at 1200 amps, you're already going to have all of your work done. So at that point, it's going to be really easy to go down to 800, 600, 400, and 200. Then we will see fully labeled systems. At that point, the challenge becomes maintaining those labels and making sure that the information that we used to develop them is current, and we monitor that. And the standard, we're going to get there, Tom, right?
Yeah.
The standard is going to be a minimum of every 5 years.
Yeah, so it's interesting. I'm showing that the 11016 label. This label here. I can't remember what year went into the National Electrical Code, just from a general arc flash label. But then 11016B changed in the 17, or was it? I think it was the 17 cycle, and it's modified a little bit. I think it was the 17 cycle that label went in, right? And that this was a panel one, making panel one change, but. This label here follows suit with the table methods that we have in 70E. But to your point, you could use either one of those methods are covered in 70E, and then you have the standard incident energy labels that we always do from a calculation perspective. So there's various ways to address the whole labeling perspective. But this is that first foot in the door, where if you were going to try to expand these types of requirements to other locations, this is probably a good place to start.
Absolutely, absolutely. And, it's all about where the rubber meets the road, where that individual that's going in to energized equipment. We've got justified energized work. This is a type of label when we do an incident energy analysis that individual needs, because now they're going to know the arc flash boundary. They're going to know what they need to wear with respect to arc rated clothing. If you go back one slide, Tom, what you'll see there is the NEC requires the fault current and the clearing time. And that's not as useful to somebody that needs to pick PPE, but it was the only way for us to get where we needed to be, to build an exception that drove you to 70E. And one thing I do a lot of is 70E training. And Tom and I do a lot of that together. And 70E training has to be practical. And one of the things that we have to drill into the men and women in the field, and you can look at it on this label, is that it's all about current and time. Yeah. And they need to understand that. The amount of time is directly proportional to the energy created in an arcing incident. And typically, when we get into current and time, Tom breaks into a song by the Rolling Stones and something about time. How's that
going there? I'm not going there.
All right. Normally he does, but he's a little shy today.
No, I don't. I think it was Gabe Paletti who already told me I don't have a singing voice. I should just stick to guitar. So, yep, that's okay.
Okay.
All right. So let's move on to the next one. All right, here we go. This is always a good question. How overcoming, you have all of those, especially when if it's senior leadership or senior engineers in any organization who don't understand the importance of 70E and relevance of it to their industry and their business. How do we handle this type of a question, Jim?
Well, before we jump to this, there is one question, there is one statement on the WebEx, and I think we should address that briefly. And it says, if you ever have an electrical incident at your site, I guarantee you that OSHA will look for arc flash labels as part of their investigation, and they will consider NFPA 70E enforceable. And I appreciate that comment, but I'm going to say that, and let everybody know that that's not true. NFPA 70E cannot be enforced by OSHA. OSHA has their own requirements. Now, if you go way back in time, there was an incident in Ohio where the area director actually cited NFPA 70E in the alternative. The OSHA Field Reference Manual, that's the guide for the COSHA. It permits OSHA to do that. So they cited 1926-95 for personal protective equipment because we were in construction. 1926-416 because of exposure. And then it said, or in the alternative, 70E. They don't do that anymore. I can tell you OSHA will not and cannot cite 70E. OSHA will use 70E, and they will use it in a very significant manner. OSHA will use 70E to prove that, one, a hazard existed, and two, that there was an industry consensus standard that's well known that could have been used to abate that hazard, to reduce the risk, to eliminate exposure. But OSHA, if OSHA comes in, they're going to be citing their requirements. Now, if you have a fatality, and I know a little bit about that, I did 3 fatality investigations. If in your plant you have requirements for labeling, and you have a written electrical safe work practice plan, and you're not following it, now you just opened up a whole different can of worms. But OSHA is going to enforce OSHA requirements. And the only place that I know of, the only entity that formally adopts NFPA 70E is the Department of Energy. And they just recently moved, I believe, from an earlier 2000-ish addition to the 2015. So the Department of Energy adopts NFPA 70E, and that's fantastic. Does OSHA adopt 70E? Well, when they revised Subpart S in the 1910 standard, there's a lot of 70E that went in there because that's where you get your infeasibility thresholds, et cetera. But uh, construction, construction is way behind. OSHA doesn't care about construction when it comes to electrical hazards. They could care less. Lockout, tag out in construction is render inoperative.
Yeah. Isn't
That's
it,
all-
are
that's
they
all
more
it is.
concerned, are they more concerned around the fall protection and things like that than they are the electrical?
Yeah, the electrical in construction hasn't really been updated since it was created, and in 1984. You know, it's based on the 1984 National Electrical Code, the most recent revision. There are letters of interpretation when you're using OSHA requirements, and make sure that you look at those. But the thing to keep in mind here, and it takes us right into this question. Did you have something else, Tom, before we get into
No,
this
no,
question?
good. No, let's move into this question here.
Okay, so how do you overcome resistance from senior engineers or electricians about the importance of 70E when they frequently say it's never happened here or happened to me?
Yeah.
And they're people that are basing their actions on their collective experience. It's what they're doing. And when it comes to training, it's without a doubt one of the biggest challenges that we have. And when I was full-time safety coordinator 15 years ago, if you asked me where we were, I would tell you, with respect to electrical safe work practices, we were in a bad place. 15 years later, where are we? We're in a much better place.
Yeah.
What's the number one reason for that? The number one reason for that is training, and primarily the training of young men and women that are coming into this business.
Absolutely.
And they understand the hazards, and they understand that there's feasible, practical methods to eliminate and to reduce likelihood and reduce exposure when justified energized work is required. Now, we could be at 100%, but we would just have to take every wireman over 50 and shoot them. And then that would create a different problem. But the biggest problem here, when you got senior engineers, electricians, company owners, is that they are not trained. One of the biggest mistakes that I see with contractors and owners is that, they say, hey, we got to get all over this electrical safe work practice stuff, get all the men and women trained. But they don't get trained themselves. Middle
Right.
management doesn't get trained. Upper level management, and they're the ones making the decisions.
The other thing too, I was working with a few contractors, and where I see success from senior leadership is when their person who's in charge of safety, or if they don't have somebody who's in charge of safety, the person who takes it on because they understand the importance of safety in that organization. If there's communication that goes on between all those little incidents that add up that probably senior leadership doesn't get exposed to and isn't aware of, and when you can relate that, a lot of your senior guys, a lot of your leadership team is going to relate to financials, and if they can see how where the dollars are going due to all of those little accidents that occur, the more of those little close calls and whatnot, that adds up to that really big one that's going to happen probably in the future based on statistics. But what I've learned is that when they can relate the financial impact up through the organization, that's when you get some of the people who may not care about, the guy got hurt on the job, so he spent a couple weeks off the job, but we got somebody else in, and we were able to get the job done on time, etc. And like my uncle used to tell me, you'll heal, type of deal. But when you start relating and find out that, hey, this may impact when I go to bid another project, they're going to be looking at how many reportables you had and all this other good things that may make it so that you're not getting some bids, or you're bidding, but you're not getting the job, and you don't realize it's because your safety record that you're not getting it. You're not tying those numbers together. So I think, that holistic approach and making and communicating up is important.
Yeah, and to try to give, I don't know who sent this particular question in, but to try to give you some very practical, some real life tools to try to address this. One of them is training. Okay, and you can overcome that resistance by making sure that owners are trained, that they understand the hazards, they understand the consequences. And in many cases, when an owner is told, hey, we're going to need to create an electrically safe work condition. And, most people would say, we're going to create a shutdown. 70E, a shutdown isn't an electrically safe work condition. You need to follow all of the rules for an electrically safe work condition. Yeah. And the owner pushes back. And the owner pushes back for very good reason. He's had you doing work in there for the last 25 years, and you never shut that equipment off.
That's right.
So what we need to do is train the owner. We need them to understand that we are the best value, that we have their best interests at hand. And when they find out that if something does go wrong, that they could potentially lose their equipment, when you explain to them in no uncertain terms that instead of a scheduled shutdown of known duration, you can get an unscheduled shutdown of unknown duration, they sit up a little bit straighter. I mean, because that hits them in the wallet. And money, a contractor, for example, let's go into construction. He gets somebody shocked, they fall off a ladder. Another trade sees it, they call 911, guy's unconscious. Paramedics take him away. Well, in most cities, they have a deal where when they go to a construction site or an industrial facility and there's an injury, they call OSHA. Now OSHA comes, and I guarantee you that contractor is getting cited 1926-95 because there was no PPE. If there was, he wouldn't have had current flow through the body. He's going to get cited with 1926-416 because there was exposure. If there wasn't exposure, then there would have been a citation. And OSHA will interview the injured party. Yeah. And when they find out that you didn't specifically provide any training for that individual, now you're getting cited with 1926-21. So that's 3 times $13,600. You do the math. Wow. And that's chump change. Because what happens is once you get those serious citations, you open a 5-year window. And if you get a similar citation, it's repeat or willful. And now the fines are $136,000, and you can't get insurance anymore, and you're off all of those bid lists. But the easiest way to get this done is that when upper-level management says, you're going to do this, we don't care what 70E says, documentation.
Right.
Documentation. Fill out that energized electrical work permit and then forward it to them and say, look, we believe this to be an extremely hazardous task, but as per your direction, well, you're not going to get an email back from that individual. You're going to get a phone call. And the first thing they're going to tell you is don't send any more emails. Because once they realize that if something goes wrong, they're going under the bus, they will change their direction.
Absolutely. Great. Awesome.
And Tom and I don't have any problem throwing you under the bus. So
that's right. There you go. I love it. All right. I say we move on to the next question, huh?
All right.
Okay. This is a good one because I think it falls in line with suits similar to the previous, having a safety professional that's requiring full arc flash PPE just for the electricians to enter an electrical equipment room. I've heard this before over and over and over. And the basic question here is, do you need PPE just to stand in front of fully enclosed equipment? So you take a look at a piece of equipment like this and you say, I'm going to walk up, or actually this picture is from a piece of equipment that is near a mail room inside of a large commercial building. And there was always that question of, okay, if I'm going to walk in front of that equipment and read the meters, looking at my energy data, or it's in an area where you have traffic, there might be a door there and you're walking past through that. There are people that will tell you, hey, you need to get in full PPE just to stand in front of that equipment. What do you think?
Yeah, absolutely, Tom. This is a question that comes up all the time. And what it points to is, again, and we're going to keep going back there, it's a function of training. What this points to is a lack of fundamental training for that safety professional. And, he or she, they get an A for effort, because they're going to go as conservative as possible and say, before you even walk into this room, you're wearing all of that PPE, because they don't understand. So let's just jump into the standard for a second here. And Tom, am I still with you there? I think it says join the meeting. I got lost here.
Hold on. Yeah, I lost you.
All right.
I
Well,
lost your image.
I'm connecting back. I don't know. Can they still hear me?
Yeah, we can still hear you fine, Jim. I can still hear you
Okay.
fine.
All right. Well, I don't know what happened, but it's the WebEx piece here. Maybe I'm. Let's just see here. I should be back in now. Am I back in now?
Yeah, go ahead. I'll look for you here. Hold on. Keep coming.
Yeah. I don't know what happened, but when you're doing an arc flash risk assessment in 130.5, it tells you that you always have to do an arc flash risk assessment. But the very first thing you need to do is determine if there's an arc flash hazard. That's the key. You must first determine if there is an arc flash hazard. And the definition of arc flash hazard, I'll refer to the standard so that I don't misquote it. The definition is a source of possible injury or damage to health associated with the release of energy caused by an electric arc. Now, that's a good definition. And what I really like about it is it's short and it's sweet. It's not a 6-sentence definition. But what happens here is we have two informational notes. And informational notes in the National Electrical Code are extremely important. In NFPA 70E, they're critical. They're fundamental to the understanding of how to apply the standard. The first informational note tells you that the likelihood of occurrence of an arc flash incident increases when energized electrical conductors or circuit parts are exposed. We'll stop there. That's pretty easy. If we see exposed energized conductors or circuit parts, we know we have an arc flash hazard. Then it goes on to say, or when they are within equipment guarded in a guarded or enclosed condition, provided a person is interacting with the equipment in a manner that increases the likelihood of an arc flash incident. There's a second informational note that tells you where to go for that information. It tells you to go to table 130.5C for examples that increase the likelihood of an arc flash incident. So the committee gives you those examples. So one of those examples, one of the best examples, would be racking a circuit breaker into switchgear or racking out a circuit breaker. We are interacting with the equipment that increases the likelihood of an arc flash incident. The last sentence of the first informational note, ties us back into the installation requirements. And it says an arc flash incident is not likely to occur under normal operating conditions when enclosed energized equipment has been properly installed and maintained. And that is a true statement, and it's incredibly important. We cannot say that this electrical equipment that is listed and installed in accordance with the National Electrical Code, it was inspected. We can't say that the day after it was inspected, it's inherently dangerous, because it's not. It is not. And that takes us into normal operation. And that's always an interesting question when we go there. And, how many normal operations are there in the United States of America every day? How many circuit breakers and switches get thrown? It's not in the hundreds of thousands. It's in the tens of millions.
Yeah.
And it's normal operation. So the key is, if you've got exposed parts, you've got an arc flash hazard. If you're interacting in a manner that increases the likelihood of an arc flash, you've got an arc flash hazard. And if you go back to that question, there is no arc flash hazard, because they may simply be going into that electrical room, that electrical area, to take a look at a panel schedule or other. If we were to agree with this safety professional that you needed PPE to go into an electrical equipment room, think of all the office spaces where we've got a panel board in a hallway.
Yeah.
That means everybody working in that facility, when they walk down the hallway, would have to be, decked out in Category 1 or Category 2. It's just not, it's not feasible.
Yep.
And it's not necessary.
All right, hold on one second, Jim.
I don't know why I lost you there before. I think it was because I didn't.
Well, I got you now, but man, I can't. If I get out of this mode.
Well, while you're trying to figure that out, I'll just take you a step further when we take a look at the definition of arc flash hazard and other requirements in the standard, we get into likelihood, right?
Yep.
And likelihood is extremely important when we're talking about applying all of these rules. And let's just take a look at likelihood. How many of you, I mean, I can't hear you, but how many of you have ever flown on a commercial airline for work or for pleasure, to go on vacation? So let's stop and think for a minute. Is it possible that the plane you're getting on crashes? It is. It's possible. Is it likely? The answer is no. It is not likely. If it was likely, nobody would fly. So go on that vacation. But we have to also keep in mind, when you go to that table 130.5C, that there's a note to the table. It's a table note, which means it's not an informational note. It's enforceable. And we tell you there, and this is extremely important, we tell you there that likelihood is just one part of a risk assessment. So if you're talking about normal operation of a circuit breaker, you take a look at likelihood and severity. So, we're going to operate a 200 amp molded case circuit breaker, right? Brand new, was inspected, 6 weeks ago, right? There is no likelihood and severity of exposure. If something did go wrong, we can identify that. Now let's take a look at a 4,000 amp low voltage power circuit breaker. Now we can take a look at likelihood and we can say, you know what, it's brand new or it was just maintained. It's not likely. But if something does go wrong, we have a completely different level of severity. And that's up to the user. 70E, I would really like to try to figure out how to do this, but 70E doesn't come with an easy button.
Yeah.
If we had an easy button, then you could just hit the easy button and say, what do I do? And many people at this point will say, well, why don't you add that in there? And we can't. We can't, because it's a standard for electrical safety in the workplace. And we've got a lot of different workplaces out there. And we are all very familiar with our own. But we have to recognize that this applies to all.
All right. So the image I got up on the screen right now is that transformer, and I put that up there because I think that leads us into one. It puts us into the next question a little bit. But when you see a facility that is not very well maintained or does things like this, a transformer is supposed to be ventilated. It's supposed to have some air circulation and things of that nature. And obviously in this image, you're not applying that product correctly. And there's probably, if that facility is full of these types of issues where you have openings in equipment that shouldn't be there, so it's not well maintained. When you have a power distribution system that's not being maintained, it's not being appropriately treated, then you could have hazards, right? I mean, you could have some unintended hazards that are there, that in that room or in those areas of your plant that you may want to say, I got to treat this a little differently because I've got equipment that hasn't been maintained correctly. Maintenance is
and I think it was last cycle we added, or the cycle before, we actually added into 130.6 that electrical safe work practices had to observe workspace clearances. And the reason for that, I mean, we didn't try to duplicate what's in 110.36 or 110.33 or 32 too. What we did was we said that you have to observe those working spaces. So we could take a look at this picture here, and it's not likely that transformer is going to require examination and/or adjustment while energized, but it is likely that panel board will need to be opened and examined or adjusted while energized. We could be in there troubleshooting, which would be infeasibility.
Yep.
We could be in there getting that done in that panel board. And I mean, we've got all this trash and cardboard, and workspace clearance is just that. It's just to give me the space that I need to perform my task. It has nothing to do with an arc flash foundry. It never did.
Nope.
It's just a minimum amount of space for me to get in there and work on the equipment. And the other piece that workspace clearances does is it also ensures, when we follow all of those requirements, that I don't have, for example, a panel board above a transformer. If I did, then I literally have to lean on the transformer. I have to lean on grounded metal surfaces to work in an energized panel board. So this is not uncommon. I think that in offices, the transformer just becomes an ideal place to begin stacking things. And there's a new requirement in the 2020 NEC that says where the top of the transformer is horizontal,
Yeah.
and it's accessible as this one is, and we have to mark the top that it's not for storage. We don't tell you exactly how to mark it. We don't give you the words, but we tell you that you have to label the top of that so that there is no storage, because it's going to contain heat and it's not going to allow that transformer to dissipate heat the way that it was designed, the way that it was listed.
Yep. So I got another question. I got a question that came in privately to me on WebEx. Are you allowed to walk into an electrical room if the incident energy of the equipment is rated higher than 40 calories per centimeter squared, given that you're not interacting with it?
The answer would be no. I mean, you could go into those rooms.
Yeah.
I have seen primarily in service equipment, but I have seen many installations that were labeled, and the equipment said, danger, no commercially made PPE, no work permitted, no commercially made PPE, nothing known to man is going to protect you from going into this equipment. Well, as long as that equipment is properly installed and maintained and it's completely enclosed, then
Right.
yes, you can walk into that room. What happens in many of those situations is that it's service equipment, and the engineer knows what the incident energy would be on the load side of that overcurrent protective device in the service equipment. So they can take a look at that. And, it might be 2 calories. But since it's a 480 volt service, it's a Y connected secondary, since it's not self-extinguishing, the engineer takes a look at it and says, well, if we get a fault on the load side that migrates to the line side, now what's my incident energy? And the engineer can't calculate that. The reason they can't calculate that is because it's all about current and time. They know what the current is, but there is no upstream overcurrent protective device that's going to open on the line side. So we get these crazy high numbers. And that's why we have seen the industry begin to move in a direction to try to require barriers for years, right? And for decades, actually. We had requirements in Article 408 that said for switchboards and switchgear that were service supplied, we had to have barriers on the line side to prevent inadvertent contact. We probably should have thrown one of those pictures in here, but that's what it was all about, prevent inadvertent contact. So we added panel boards into that list in Article 408 in 2017. This is just service supplied now. And that's why contractors all over the country, if you were to go into any home center, Home Depot or Lowe's, and take a look at the panel boards that are readily available for purchase, you're going to see that they all come with boots for the line side termination. Now, they don't eliminate the possibility of contact. Some of them do a superior job and may just eliminate the possibility of contact. There's an example right there. Tom just pulled that up. So if this is service equipment, and we've got problems. I represent the electrical construction industry, and when it comes to NFPA 70E, we cannot go in to service equipment if we're following the requirements in NFPA 70E, because we're going into that service equipment. We've got exposed line side terminals, and there's no way we can apply the tables. If we're applying the tables, okay, we can take a few steps and determine the available fault current, but we can't estimate the clearing time of the upstream overcurrent protective device because there isn't one. So from a very practical sense, the only certainty in that scenario is that the work is going to get done. That's the only certainty in that entire scenario. That work is going to get done. If there's work to be done in the service equipment, they're going to do it. And I know what they do. They wear the highest rated PPE that they have. So now we've got requirements, and it's now moved into Article 240, okay, that any service equipment, anything service supply, has to have barriers to prevent inadvertent contact. So that's a change in the National Electrical Code. So that's going to impact a circuit breaker enclosure, a panel board, switchboard, switchgear, a SUSI rated transfer switch. Anything that is service supplied is going to have protection from inadvertent contact.
And that's in Article 230 for services.
Absolutely. And Tom, that takes me to a question that comes up all the time. And this, I'll put it into a panel board, but it comes up all the time. And I get a phone call from a contractor or an individual on a job site. And they say, Jim, we're going to go into this panel board. Now it's a tall panel board, and there's a main on the top left. And we're going to open the main to this panel board. We're going to, we've done our shock risk assessment. We've done our arc flash risk assessment. We're applying the tables in NFPA 70E because we don't live in a world that's labeled in construction. And then they're going to remove that dead front, and they're going to test the bus to verify absence of voltage with a portable contact type test instrument. And then they say, at that point, we don't need to wear PPE, do we? And my response is, yes, you do.
Yeah.
Because you still have exposed energized conductors and circuit parts on the line side of that circuit breaker. And as per the definition, and we went into those informational notes, we know that if there's exposed energized conductors or circuit parts, there's an arc flash hazard. But let's take a step back. Let's take a look at what they did in that scenario. By opening the main to the panel, they de-energized all of the bus inside the panel board, all of the circuit breakers, and the potential for any of the load side of those circuit breakers to be energized. So what did they do? They significantly reduced the likelihood of an event, but something that we must understand is they didn't eliminate it. They didn't eliminate it. So whenever there's exposed energized conductors or circuit parts, you have an arc flash hazard.
Yep, absolutely. All right, you want to move on to the next question?
Yeah, let's do it.
Let's do it. All right. Okay, we have a low voltage switchgear that has not seen any maintenance in 8 years. What additional steps do we need to take when switching and racking? So,
yeah, and this is a good one. But before we get there, Tom, we just, Don Gannier weighed in.
Yeah.
And I know this was something that he submitted proposals and public inputs on as well as I did. But he's talking about the big step that we took for worker protection in 230.71B with 6 disconnects. Do you want to weigh in on that a little bit, Tom? I think it's pertinent to that last question that we just had.
Yeah, sure. So if you think about one of the most hazardous areas in a power distribution system is the service entrance equipment, and I would also say that first panel board on the secondary of really any transformer. Because to your point earlier, the clearing time is based upon the upstream overcurrent protective device. And so what we did I think we had a perfect storm going on from a National Electrical Code perspective. You had changes for the line side barriers in 408 in the 2017 code, but they had to put an exception in for when you had a panel board that was leveraging the 6 disconnects inside of an enclosure. And because you can't barrier the whole bus, because when you take that dead front off of that enclosure, you're staring at either a copper or aluminum bus and 6 disconnects. If you just picture a panel board in your head. So you had that going on. You had 24087 and 24067, the discussions around 1200 amps and above, which, in many cases, that's going to be up there close to the utility, close to your service entrance equipment, or be your service entrance equipment. And then you had the labeling requirements in 11016B that was going on. So you had all of these discussions going on about the hazards and incident energy and all this good stuff. And then you had that one exception that stuck out like a sore thumb, and somebody asked the question, if that's such a hazard, if we're going to require barriers for these other service entrance equipment, but we're going to give you a free pass on this six breakers or 6 fusible switches inside of the same panel board, that doesn't seem right. So the change we did in 230 with regard to modifying for the 6 disconnect rule, we didn't get rid of the 6 disconnect rule. We simply said you need to have barriers around each of those main overcurrent devices. You're never going to see a six circuit breakers or 6 breakers in a panel board for service entrance equipment. You're going to have to break those out as one panel with a main or 6 separate disconnects feeding sub panels, and that really addresses a safety concern from if you think about a design perspective. That's a great practice to have, is to sit down and say you're going to change your design a little bit to make things a little safer, and that's sort of what we did for those service entrance equipment. So I think that was a really big step forward.
Absolutely. The 6 disconnect, you're absolutely right, Tom. The 6 disconnect rule is still there. Just, the general rule is 6 enclosures. And then there was one other question, and this will be real quick. And somebody writes, what if they install a temporary barrier around the line side of the temporary breaker? Can you back up? Can you put the picture back up that you had of the inadvertent contact protection?
Yeah.
You still have that available?
I still have it right here. Hold on.
I don't know about a temporary barrier, because a temporary barrier to me would be somewhat less than something that was designed for inadvertent protection from inadvertent contact. But keep in mind that everybody that uses 70E, okay, is going to apply 70E. So if they apply a temporary barrier and they say that, hey, I don't have any exposed energized parts, then they're going to move forward in that manner. I can tell you that if you throw that picture back up, Tom, it was just there.
Yep.
I can tell you that there are employers out there on panel boards. They are installing devices like we see here that are made specifically for the purpose of inadvertent contact protection, and they are looking at that. There are some. They are looking at that and saying there is no exposed energized conductors or circuit parts, so I don't have an arc flash hazard. And all of this here, we're playing catch up. I don't think we're ever going to be there with the Canadians. The Canadians, never allowed 6 service disconnects, and the Canadians have a rule for a metal enclosure on the line side.
Yeah.
So if we were ever to get there, then that would be the beat all end all. I think we can go to the next one. I just didn't want to miss those questions. They were good questions.
That's a good point. Good point. All right. So this one here, we didn't hit this maintenance. So this is talking about maintenance and maintaining your electrical equipment periodically. Now, what I would say is, you have to look at. Now, this talks about low voltage switch gear that hasn't been seen maintenance in 8 years. You have to take into consideration from the manufacturer, what do they recommend from a maintenance perspective? How often are you supposed to do maintenance, and things of that nature? So I always say, obviously, NFPA 70B is focused on maintenance, but we always try to make sure that people understand the manufacturer is going to have guidance and give you guidance on how to maintain and properly maintain and the frequencies of those. we do fall back on NFPA 70B as well. But so Jim, you have a piece of equipment, and 70E is references from a hazard awareness and whatnot. You've got to do that hazard analysis, and a piece of equipment that's not maintained or hasn't been maintained. How do you handle that? Even if you shut it off, to your point, you're going to have to establish electrical safe work condition, which will include dressing for success in that regard to make sure that you have to assume that it's energized, right? What do you do?
Absolutely. There's, working for years in the construction industry, if somebody asked me a question like this, and they said, what additional steps do we need? I'd say, well, how big is the crew? If they say 6, I would tell them to supply each and every one of them with a rabbit's foot. But then I would get into, because I would just try to make them understand that this is not something to just get involved with and jump right into the equipment. Although, in my experience, I've seen this happen over and over again because prior to training, because the men and women in the field don't understand how to properly perform an arc flash risk assessment. When we perform an arc flash risk assessment, and you're using the tables, one of the other things that you need to do is you need to determine the operating condition of that device and its condition of maintenance. And you have to understand what equipment requires maintenance and when that maintenance is required. So, for example, let's assume that this is service-supplied switchgear. And even with the change that we made it in 230.71 in 2020, switchgear is fully compartmentalized. So you could have 6 disconnects in that switchgear. So let's assume it's 6 low-voltage power circuit breakers in switchgear, and they're telling us there's no maintenance in 8 years. When is maintenance required? Well, NFPA 70B, the guide for electrical maintenance is going to tell us every 3 years those low-voltage power circuit breakers need to be maintained. And the manufacturer may say, well, it's 5. So let's take a look at it. Somewhere between 3 and 5 years, they need to be maintained. There's moving parts. There's grease, there's lubricants, and if they're not moved, if they're not lubricated properly, that can turn into cement, and you can increase your opening time, or it may not open, or one pole may not open. So in a situation like this, and I had a contractor come to me with a scenario similar to this, and they were doing a switchboard replacement, and he had to open a 2,000 amp frame low voltage power circuit breaker that hadn't been maintained in years. And I said, well, go to the owner and tell him, get that thing maintained. And he called me back. He said, well, he's not interested in maintenance. Well, then I said, you need to put in writing that the act of opening that device, just opening it could cause that low voltage power circuit breaker to fail, and he could lose all of his equipment.
Yeah.
And in this case, that was a risk that the owner was willing to take. And again, in all of these scenarios, the work's going to get done by somebody.
Yeah.
So in a case like this, the only way you can open that low voltage power circuit breaker is remotely. And what Tom has on the screen, and that's medium voltage, right, Tom?
Yeah, that's medium voltage, yeah.
Yeah, so you've got a circuit breaker that is getting racked out, and he can turn the little video on by that remote device. But you can buy kits that'll work with every low voltage power circuit breaker ever made, and it'll open them whether it's a switch or a push button. It'll rack them all out, and I think if you buy one of those kits, it might be $7 or $8 grand. That is cheap. That's pennies, because now you can open that circuit breaker with an individual. It could be a cord, it could be a 50, 75-foot cord, it could be Bluetooth. It all depends on what you're buying. And now they open it remotely. And so the thing opened and it didn't blow up.
Yep.
So far, so good. Now you got to rack it out. So now there's another device that you set up, and it's got a little motor on it and a crank arm. And now you get 75 feet away, and you rack that circuit breaker out until it comes out and it's fully racked out position.
Yeah, they can
So,
rack.
in a situation like that, when maintenance isn't performed, on a given overcurrent protective device, you cannot count on that device to open the way that it was designed when it was installed.
Yeah,
You'd have to go upstream and find a device that was properly maintained and do your arc flash risk assessment on that device.
Yeah, and the further up you go, so as you get up, like this is medium voltage equipment, but like you said, there's those devices that you can fit on the front of a circuit breaker or switches and remotely operate those, and there's some of them are coming with. I know, like, and I saw Russ Safried on one of these, the chicken switch guys. They can mount those equipment, and we have equipment. Most manufacturers will be making stuff like that goes on the equipment and gets you. Either you can do it, you can rack things out, you can open breakers, you can close breakers, you can do a lot of that activity remotely. And one of the things that we're doing from a manufacturer's perspective, we're trying to do a lot more of that behind closed doors. So you see things like our arc flash motor control centers. We have a panel board and a switchboard that you can take the breaker in and off the bus, molded case circuit breakers, and remotely take those in and off the bus while the door is closed. And that's, I think you're going to see more and more of that. We have the safety disconnect switch that has the disconnect on the top of the equipment that's got a closed door. It's got a window so you can see the visible blades. We do the presence of voltage indication. And when you open that device, you can't open that door, but you can get to where you can access the fuses and replace fuses. So there's a lot of new technologies and a lot of, I guess I don't even know if I'd call it a new technology, but it's more like the ability to that you have to just change and design things a little differently, right? So I got a couple questions. So I got one that came. Christine Porter had a question on Facebook. She says, "Do you think there will be a requirement to have a log of the maintenance posted at the gear, much like you see in public restrooms, that when they show you that when they were last cleaned?" So a log of maintenance would be a good thing if you think about it.
Well, if you put a maintenance log, you have to put a hand dryer right next to
it. Yeah.
I'm only kidding. But one of the things, and I'm sure Chris knows that this is coming down the pike, and she wanted us to get into that. But one of the things with newer circuit breakers today, you can buy them with the capability of storing that information and relaying that information to you, so that if you had to, if you had a device open and you're the maintenance guy, and a 600 amp electronic trip molded case circuit breaker just opened, well, you can go into the app and find out what it opened on. You can find out whether it was an overload. You can find out whether it opened under short circuit conditions. You can find out when it was last moved, when it was last opened, when it was last closed, etc. So there's a lot, and the ability, Tom, to remotely open and close is, I think it's significant moving forward with electrical safety, but we've got to get design engineers interested in speccing those things.
Yeah, and I know our latest, our new line of power defense circuit breakers have the conditions of maintenance for those breakers built in, so I can tell you all of that information that you were just talking about. You can get right from that device, or you can get, here's the other part of it, a lot of this stuff you can communicate with over the computer remotely. So I could get condition of maintenance, I could remotely open those devices, and if you think about it in the design phase, we can install equipment so that you can remotely close devices, with proper passwords and all this other good stuff. But you can do a lot of that action, not just from an umbilical cord, but from a computer in an office somewhere. So, there's so many things that you can do remotely these days. But to your point, Jim, design engineers, specifiers, and owners have to ask for that, because it's not a National Electrical Code requirement. It'll help you in your 70E world from a life safety perspective and worker safety, but it's not required anywhere. So these are design principles and best practices that that you just have to think about. So, and what I'm going to do, Jim, is I'm going to put, I've been making notes every now and then. I'll put links to the bottom at the bottom of this YouTube video. I'm going to link to a case study that I mentioned earlier, and I'll link to our power defense predictive our predictive maintenance. We have that as well, but also our condition of maintenance capabilities. So those are things that design engineers and owners need to be putting, to your point, in specifications and all that jazz. And not to diverge us a little bit, but Derek Vixtel asked a question for you specifically. You know, I mean, he didn't say, hey, Tom, what's your perspective? He just said, question for Jimmy. So he really values your opinion on this one. Would you consider those barriers, the barriers that we were just looking at? So I'll put the picture up here just so we know what we're talking about. His question is, would you consider those types of barriers in service equipment as being not exposed energized parts?
And that would be, that could only be done, and we've had this discussion within 70E committee members, that could only be done on a case-by-case basis. You'd have to take a look at the individual manufacturer's method of providing protection from inadvertent contact. I have seen some manufacturers and the assemblies that they put together, it's like an eighth of an inch of heavy, I don't know what kind of material it is, but it's a foop, it comes around, and then there's tie wraps that actually work almost as like shrink tape and tighten it in there. And there's no way, the one thing that I look at is a fish tape, a metal fish tape, and not a metal fish tape with an eye on it. Somebody just cut that eye off. And could that eye make its way in there? So one thing that, and this is going to be a decision made by the employer. This is not an easy button. I would love to have an easy button so that everybody using 70E would say, okay, what do I do now? So you're going to have to make that on a case-by-case basis based upon the material and the method used to prevent inadvertent contact and the task at hand. So both of those would have to come into play for you to make that determination. I can tell you this, that requiring those barriers just like that was one of the greatest leaps forward that we've ever done in the National Electrical Code with respect to safety, because in service equipment, when somebody does come in contact with the line side, and in all of the situations that I've seen, it occurred inadvertently. There was no intent to be in that area. Somebody was holding an equipment grounding conductor, for example, and they're going to land it, and it springs up and in. I mean, there's a lot of people that are in the graveyard today, because just that happened. But what that does is that significantly reduces the likelihood of an incident. Now, if somebody were to ask me and put me on the spot and say, in all cases, does that now suffice as not being exposed? I would have to say no, because I would have to see each one. And I think that some manufacturers are doing a much better job than others. They're not all created equal, let's put it that way.
I hear you.
And there's one here, Tom. This is a quick question, but this is,
sure.
And it's not on this topic, but it's one that comes up all the time. And Ron asks, what about manholes that have multiple circuits running through them? Do I need to de-energize them all to enter and or work on one of the circuits? That's a really good question. So there's a lot that comes into play. We're not going to get into confined space requirements, but in order for you to get into a confined space, you need to be trained. And we're not going to, so you've got an attendant, you've got an entrant, you've got an entry supervisor, and then you're going to take a look at the number one killer in confined spaces. The first thing you're going to do, the number one killer is a hazardous atmosphere, and the number one hazardous atmosphere is a lack of oxygen. So let's assume that Everything's perfect with atmosphere, and we've got data on the space. Now, when you go in, you have to determine if it's a permit required space, meaning, is there a hazard in that space? So I'll just give you a couple of quick examples. In that manhole, I've got four 480 volt feeders, 500 kc mil, THWN, and they're neatly racked, no splices, and they're wrapped around the left side of this manhole, in and out of the bells into raceways. So by themselves, they don't represent a hazard when I go into that manhole. If I go into that manhole to take a large fiberglass fish and just push it in another conduit, somebody's feeding it down to me, push it into another conduit and pull a tape in to get a measurement, my task is not in any way, shape, or form create a hazard with those existing feeders. But if I went into that manhole and I had load breaks, now we've got a problem. We bump a load break, we could have a failure. If that manhole contains old lead-covered splices, you got a completely different scenario. If
Right.
that manhole is underwater for 4 hours every day, you've got a completely different scenario. So you would have to take a look at each exposure in a manhole. You'd have to take a look at what's in there, whether they're service conductors, they're feeders, etc., and then you would have to make a determination. Tom, you and I offline, we got to work on that easy button for 70E, because if we're able to do it, we'll make a fortune.
Oh yeah, absolutely. All right. There was another one came up here too. It says on YouTube, Jason asks, what if my customer has arc flash labels in place, but they do not maintain any of their electrical equipment? And in my perspective, that label is good when they put it on, but if the condition, from an engineering perspective, if I'm going to do an arc flash study for somebody, and I go to that facility to do my walk down to update the one line diagram, and I look at the condition of the equipment, and I see that it's not maintained, you've got to have that realization that if I'm going to do this study, and I know that you've never maintained those circuit breakers, the clearing time on the circuit breaker could be a lot longer than what I'm going to be using, because I'm using time current characteristic curves, assuming that it's a well-maintained device. If I'm not taking that into consideration, I can still give you numbers. I mean, anybody can generate a number, but even if you use the table method, no matter which methods that you're using, if it's not maintained, the energy numbers, the labels aren't worth anything really. So at some point, somebody has to educate that owner that, if I'm going to do your arc flash study, I'll do this study for you, but if you're not maintaining your equipment, you really can't rely on these numbers. You can't rely on that label, because you don't have equipment that's going to perform the way I said it was going to perform inside my study. So what you'll see is you'll see what they call assumptions, right? Or notes at the beginning of the report that'll tell you, this system is not maintained. If it is maintained, this is the performance you could expect. But if it's not maintained, your numbers that you calculate, even the table methods that you're going to use, your best bet is to start talking about remote opening, remote closing, and consider modifying your practice as far as a maintenance perspective. Get a contract with that customer. That's the opportunity to sit down with the customer and say, look, I'd love to take your money to do a study, but in reality, you need to maintain this. Let's get that done first. And then we'll do an analysis in combination with, if you're an organization that can provide the services of maintenance, then by all means quote that and quote the study. If you are just a study kind of guy, I think it's really on our shoulders to educate the owner that, look, I can do this study for you, but you need to perform maintenance, and hopefully you have some relationships in the electrical industry that says, hey, these guys can maintain your equipment. Let's get a maintenance program put together, and we'll do the study. And as we're going down through creating that accurate one-line diagram and entering all that information into the systems analysis studies and creating your short circuit calculations, doing your equipment evaluations, and doing your arc flash evaluations, all of that plays a role. It's a package. You're doing that with the organization that's also doing the what do you call it, the maintenance on that equipment. So I would pair those two together, and if your label's not going to be your label is not going to be any good no matter what, unless you're doing your maintenance. So that's sort of where my head's at on that one. I don't know about you, Jim.
Yeah, no, maintenance, if we've got equipment that requires maintenance and maintenance has not been performed, then without regard to the method that you use for an arc flash risk assessment, you're in, you're spinning the wheel. You're just guessing. Is this thing going to open in 1.5 times? Is it going to open? Is it going to take twice as long to open? Is it going to take 3 times as long to open? And the big question is it going to open at all? So if I had equipment that was labeled and it was a 6-calorie exposure at 18 inches, if it takes twice as long, remember, the time is directly proportional. So if that 6-cycle exposure existed because I had a 4-cycle opening time, if it takes 8 cycles, I've got twice the incident energy. I've got 12. If it takes 3 times, now I'm at 18. So if equipment is not, maintenance is one of the biggest problems that we have. And I don't really know how to do it, but we have to get to the senior level management, middle level management, and make sure that they maintain equipment. Now, they really should sit down and talk to some of the venues, some of the organizations that do maintain their equipment, the big pharmaceuticals, the utilities, and the casinos. Believe it or not, casinos maintain their equipment because they know that if they take 1,000 slot machines offline for 10 hours, they know there's a monetary loss. So they're going to maintain their equipment. But maintenance is huge when it comes to an arc flash risk assessment.
Absolutely. All right. That was I think that was the last one online. Let's move to the next question. We're at 117. We still got about 45 more minutes just for a time calculation. All right. So the next question, I'm told I have to update my systems analysis studies every 5 years. Is that a requirement in 70E, or is this just crazy? I don't see why I would have to update anything if my system hasn't changed. Why would anyone want me to do that? So that's a good question.
Go ahead, Tom. Go ahead.
That's a good question. I'm just my comment from I think from a 70E perspective, there's a couple areas that mention the 5-year mark. So it is raised in 70E, but a lot of different things change, right? With regard to fault currents and whether or not you modified your system or not. And sometimes a change outside of your realm, from a perspective of like from the utility side of the business, maybe they made some changes on their side that impact your system, and it could be too, Jim, if you didn't perform maintenance in those 5 years, you may at this time, and from a 5-year perspective, yeah, I didn't add anything to my plan, I didn't change anything to the plan, but I didn't do maintenance either. So a lot of my study values, some of my study values on equipment that I didn't maintain, I may not be able to rely on, and that will cause me to either make some changes to my labels or make some changes in my maintenance practices, right?
That's exactly right, Tom. Maintenance is probably the one thing that is often overlooked here, and I think you've even got the requirement itself in the next slide. But maintenance is critical here. And when we're in G, right, and this is just part of it, the incident energy analysis shall be updated when changes occur in the distribution system that could affect the results of the analysis. If you don't maintain your equipment, then changes are occurring.
Right.
Now that equipment will most likely not function, not operate the way that it was designed and installed. So that's just one piece. We could also have a change on the utility side. The utility could change transformers directly upstream of where we are at. Within the facility, I could have a circuit breaker fail. A 1200 amp electronic chip molded case circuit breaker fail, and I replace it, and I couldn't get the same exact device, so I got something close. Well, you're going to have to take a look as soon as that happens and take a look at all of the data in your study to see if that impacts your incident energy analysis. And then Tom's got the language up there for H, and that's where it tells you that you have to review it for accuracy at intervals not exceeding 5 years. And maintenance would most certainly come into play. And the last sentence there is the one sentence that most people don't read, and they say, hey, you have to label everything. Label, label, label. 70E says you have to label. Well, the owner of the electrical equipment is responsible for documentation, installation, and maintenance of the marked label. If labeling on the load side of the service point was a requirement in the 1910 General Industry Standard or in the 1926 Construction Standard, then in 70E, 130.5H for equipment labeling would be a requirement, but it's not a federal regulation. It's in 70E, but it's an option. It's an option for the owner, and somehow we have to convince more owners to get interested in labeling their equipment. In the Philadelphia area, we had a job. One of our contractors did a new building. It wasn't an extremely large building for one of the university-owned healthcare facilities. And he said, you know what, I'll throw that in there. I'll do the label. So he threw the incident energy analysis in and didn't charge the owner for it. And he's been doing their work exclusively since then. And every upgrade and every new facility that they've built, they now label because their maintenance staff began to work in that facility and realized what a safety-driven value the incident energy labels were. So I don't know how we do it, Tom, but we got to get owners interested in spending a little money.
Yeah, I know. Unfortunately, it all comes down to the almighty dollar sometimes, right?
Yes, it does.
All right. I'm gonna move to the next slide. Just before we get on to this next one, real quick, Jim? I was just looking at they still can't get your video. I got your video in on you called in on twice. You're listed twice. Do you see your name in, there? I've got you don't have video on one, but you have video on the other. And you're muted on, the one that you're muted on, the video is, I think, shut off or something. I don't know.
I don't see where I'm in twice.
I've got you in here.
I just don't see it.
I've got 2 Jim Dollards. I don't know why.
Well, maybe my son's online.
Yeah, it could be. It could be.
It could be. It could be.
All right.
All right. Well, we only got a half hour left, so let's roll the next question. As long as they can hear us, I think we're good.
Oh yeah, yeah. So, what things require an arc flash assessment to be redone? So, what do you think?
I think we just discussed a lot of that in the and obviously the submitter of this question, he says arc flash assessment. It's an arc flash risk assessment, and there's 2 ways to do an arc flash risk assessment. We can do an incident energy analysis, or we can apply the arc flash PPE tables. But lack of maintenance, changing out a transformer, anything that would impact the upstream levels of available fault current, anything that would impact opening time of an overcurrent protective device, all of those things would trigger that the engineer, whoever performed that study, do it again.
So here's another. So what I've been getting feedback on recently, IEEE released a new version of IEEE 1584. And this discussion always comes up, this question always comes up. And I see a few people on YouTube, a couple notes there. I think I saw it on Facebook as well. Some of the notes with regard to, you have to update your studies now that you have a new 1584. And I don't, in my opinion, I would not say that just because we have a new 1584 means you have to go and reevaluate your entire power distribution system based upon 1584 2018 instead of 2002. I just think that maybe at the next time you do your update, that you could consider going to the 2018 version of 1584, rerun your numbers when you do your study again. But I don't know where your head's at on this, Jim, but where my head's at is, I don't know of anybody who was not dressed appropriately based upon. I mean, we've been doing arc flash analysis since 2002 with those equations. If we're doing that analysis and we're doing those equations and labeling our equipment and keeping our equipment maintained, I don't know of anybody who wasn't dressed appropriately based upon those numbers. Just because we came out with 1584 2018 does not necessarily mean that means you need to go back and redo all of your studies in all of your different plants and facilities. What do you think about that? What do you say to that?
Yeah, Tom, you are absolutely right. And we've got a question coming up that actually says, hey, should the tables be looked at because what we did with 1584? And the answer to that is no. And you'll see coming up very soon a public input that the committee dealt with in the most recent revision cycle for 2021. And the submitter said that. And he wanted to add into 130.5, it said, whenever the method that you use to do your incident energy analysis, whenever it changes, you have to run all your numbers again. And the committee didn't say no. The committee said, hell no, for a lot of reasons. 1584 isn't the only method that is permitted. 1584 will change again in a few years. So if we go left now, we could go right later. We could see white papers that come up with information that we overlooked that will impact it again. And one of the things I would like to share with everybody is, and this is a reality, this is just being practical. Men and women aren't getting killed and injured in arc flash incidents because they were not wearing the right level of arc-rated PPE. They're getting killed and injured because they weren't wearing arc-rated PPE. They were wearing daily wear. I mean, look at the shirt that you're wearing right now. Is it arc-rated? What's it made of? Many of you are thinking, well, it's cotton or it's polyester. If it's not arc-rated, there's only one answer. You're wearing fuel. You are wearing fuel. And if you're in an arc flash, you're going to get clothing ignition. And when you get clothing ignition, it's game over. That's where we see the very high percentage body burns. That's where we see the big incidents. We need to get these men and women out of flammable clothing and into arc-rated clothing. And when there is an exposure, we don't get clothing ignition. We could have injuries. They would typically be minor, and that individual has dinner with his family that night instead of being on a ventilator in a burn center.
Yeah, absolutely. That's what it's all about. It's important to, I think the fact that you're doing it, and you think about 70E. 70E, what's the annex that gives you all the different methods? There's multiple methods that you can use for calculating incident energy and determining your, is it H?
Like that's Annex D. There's a bunch of them.
Yeah.
There's a bunch of them. But one of the other things that we need to really keep in mind is everybody wants to talk about the arc flash hazard, but get into Annex K in the 2018 standard and take a look at some of the updated information there. And it tells you that about 98% of fatal occupational electrical injuries are shock. They come from shock. 98% are shock. And there was a study that showed that a very large percentage of them, 40%, involved 250 volts or less. And what that tells us, that's indicative of a mindset. And the mindset is that 240 isn't dangerous, 208 isn't dangerous, 120 isn't dangerous. And that's a mindset that a wireman has. I know, I am a wireman. I've been there. And they think very differently when they're handling 277 or 480 than 208. And another piece that is really big, those of you that are into safety, you understand the safety triangle, okay? So for every 300 recordables, we end up with a fatality. And they ran some numbers from 2003 to 2009, okay? And there was 1,718,000 and change fall injuries, okay? And falls the number one killer in construction, of which over 5,000 were fatalities. So one worker died for every 325 injuries. That's pretty close. That's pretty close to the recordable triangle with one fatality for 300. But keep this in mind. That same paper found out that in the same time frame, from 2003 to 2009, there was 20,033 electrical injuries, 1,573 were fatalities. What that means is that for every injury, okay, for every one worker died for every 12.7 injuries.
Wow.
So it's significant. It's something that we need to be aware of. You know, we are all very interested in the arc flash hazard, but we have to keep in mind that you know, we've got the shock hazard as well, and it represents 98% of the fatalities.
Yeah, absolutely right. And there's a lot of things we can do in our power distribution system to do a shock assessment. You know, that's why those openings and things like when they remove a breaker or you remove a conduit and you don't put the knockout covers in and things of that nature, you know, all of those different areas. I walked into one facility, we were going to quote an arc flash analysis. And as part of that, we had to walk down through the facility. So they took us to all of their electrical rooms. And you would not believe the number of electrical rooms we went into, and the doors were open on industrial control panels. And I asked them, I said, why are all these doors open? And they said they want to see the equipment inside to make sure everything is okay. And I'm like, I mean, you have exposed energy. I don't care if it's 120 volts or whatnot. There was a lot of exposed energized parts in that facility, and they had the doors open for a very ridiculous reason, in my opinion. So you know, shock assessment and walking through a facility, doing shock assessment, make sure you have GFCIs, make sure that your extension cords are in good shape, making sure that you have GFCI protection, not just where the code requires it, but in many different applications, wherever you know I'm going to have a shock, I could possibly have a shock issue there. So, you know, there's things that'll impact incident energy, but to your point, Jim, I agree 100%. Shock is one of the biggest issues that we have in our industry. All right,
let's get a look at the next one.
Let's go to the next one.
More, right?
All right, let's do the next one. Some feel that DC plant work can be performed energized because the nominal voltage is 48 volt DC. In reality, the voltage actually operates at 54 volts DC, which is above the 50 volt threshold. Is this liberal view of the code?
Yeah, when you get into 130.2, you know, there's one of the things that we're doing here, and Tom, this was a very interesting question when I looked at it, because, you know, we've got nominal voltages. We use that all the time in the National Electrical Code, and one of the nominal voltages that we use is 48 volts. But one of the things that we did a couple cycles back, because of the float voltage, and there's an informational note that actually in the NEC says it could go up as high as 58. We use a nominal 60 volts there now, because we do understand that it does go above 50. And the language that Tom has on the screen is right up front in 130.2, in the front of Article 130. It tells us energized electrical conductors and circuit parts operating at voltages equal to or greater than 50 volts shall be put into an electrically safe working condition before an employee performs work if any of the following conditions exist. So that's the general rule. So if you're at 51, then this rule applies to you. And this is a very interesting concept from both the shock perspective and the arc flash perspective, because in 2015, we raised the low threshold from 50 to 100 based upon some data that we were provided with. And in 2018, we went back down to 50. But the key here is that OSHA is at 50. So if you're at 52, 54, or 58, you're over 50. So all of the rules would apply. Now, if you're at 48 volts and you're in, you'll be going to 130.2A, which is titled Energized Work, that's where you get to what I like to call the justification thresholds, okay? Because this is where we're going to tell you that the employer can determine justified work based upon additional hazards or increased risk, or infeasibility, normal operating condition, and A3 gets you into operating at less than 50 volts. And in many cases, if we do have a 48 volt source, for example, people believe that they don't need to do anything at all, and that's not true. We tell you that if you're below 50 volts, you have to take a look at the capacity of the source and any overcurrent protective devices, if any, and you have to make a determination that there is not a risk of an arc flash injury. So the best example there is we've all done something with a car battery and we made a mistake and we created an arc flash and we jumped 2 feet in the air and we were permanently scarred and our clothes were on fire. No, that didn't happen. But what happened was it scared the heck out of us. And when we went back into that automotive 12-volt battery, we were a whole lot more careful. But let's do this. Let's take 4 of those and let's put them in series. We got 48 volts. Now let's take 1,200 sets of those and put them in parallel. We're still at 48 volts. So who wants to put a wrench across that?
Exactly right.
That's what 70E tells you. You need to take that into consideration.
Excellent. And I had a slide in here. I put the table 130.4DA, which talks about the AC side. And so 50 volts across the board, AC and DC, that's the established threshold from a shock perspective, right?
Yeah, and this is the AC table here.
Right.
But this is limited approach boundary. We're really not using the exposed movable conductor. You can see that superscript C, and it'll tell you that that's associated with conductors on poles. So we're always in 3 for the limited approach boundary and 4 for the restricted approach boundary. And moving forward into the next cycle, I think we need to work some in the restricted approach boundary for 50 to 150 volts, because there's some confusion, and it says avoid contact. Mm-hmm. But there's been people that have said to me, but Jim, if you're taking a test instrument into a 120 volt duplex receptacle, you're not avoiding contact, you're intentionally making contact. Yeah. And those individuals are right. So the question there is, well, do I need rubber insulating gloves to take a test instrument to a duplex receptacle? And that raises a lot of very interesting discussion, because I'm safer using a newer test instrument at that duplex receptacle than I am plugging in the vacuum. Yeah. So if we say that you need rubber insulating gloves to test at a duplex receptacle, well, then we're going to have to get everybody rubber insulating gloves to plug in their vacuum, their Xbox, their laptop, and what have you.
Yeah, and that brings up a good point around when you go too far, when your needle goes too far to the right, or to 100, when you get that overdoing safety where you can't do anything, that's detrimental to your overall safety on that facility, because then people start to, when you get ridiculous mode, I call it, then you lose credibility, and they won't be doing the ridiculous stuff, because they're like you said, if I mandated, made my guys wear gloves and all that just to plug their computer in. When they are supposed to wear those gloves, they're not going to do it because you've established that you don't know what you're talking about. You're making them do things that are ridiculous. So,
Tom, you're absolutely right. I've seen work performed on cable tray, and we were pulling conductors. They were low voltage conductors in cable tray. We were able to do it from an 8-foot ladder, and the owner of the facility told us that we had to have fall protection on a ladder, which isn't required, right? But when you're in Rome, you do as the Romans. So they had to get 14-foot ladders and go up a 14-foot ladder to drill a hole to put a removable 5,000-pound listed anchorage in. And I went out to that facility and took pictures of them doing that and emailed those individuals and said, I just want to let you know that now you have significantly increased the likelihood of a fall by having us go up on a 14-foot ladder every 6 feet to drill a hole. And for that particular operation, they changed their opinion on whether or not we needed fall protection on those ladders. So you're right. In some cases we can push the needle too far. We have to good code has to be easy to read. It has to be practical.
Yep.
And it has to be enforceable. If it doesn't meet, those 3 list items, it's not good code.
Amen. Yep. All right, let's move to the next one. This is a real life example. It says, since it is allowed to use site-specific level of PPE on the label using the incident energy method, is there any reason they can't choose the categories in table 137C15C as their site-specific level?
That is specifically prohibited, and I think we actually added that into the next slide. And we can take a look at the last paragraph there in 130.5F. Either but not both methods shall be permitted to be used on the same piece of equipment. This last sentence is extremely important. The results of an incident energy analysis to specify an arc flash PPE category in table 130.7C15C shall not be permitted.
Yep.
And there's good reason for that. They're 2 completely different methods. They're apples and oranges. An incident energy analysis is based upon data. It's based upon a standard like 1584. We do information gathering. It goes into software, and it spits out some numbers. The table method is completely different. It's based primarily on empirical data that came from the petroleum industry many years ago, lots and lots and lots of data and exposures, and the parameters were the same. So they built those tables based upon that data. At the time, it was a controversial way to go. It was direly needed in the industry because we had nothing. And when you take a look at it now, the individuals that put that together almost look like geniuses. It works. But here is one of the big problems with taking the results of an incident energy analysis and trying to tie it in to the arc flash PPE category method. When you're in the tables and you're in an equipment category and your arc flash PPE category 2, we're going to tell you need to wear 8 calories in that arc flash PPE category 2. I can tell you that in that arc flash PPE category 2, for example, you're in a panel board, 480, 277, 200 amp, 400 amp molded case circuit breaker. There is no way you're getting anywhere near 8. You're going to be under 2 calories. The tables are primarily conservative. And here's the problem. Now I'm an engineer and I run an analysis and I come up with 7.5. Now I'm putting you in an 8. I'm going to say arc flash PPE category 2. What we need to understand is that arc flash risk assessment, without regard to the method that you choose to apply, will never, ever be a perfect science. We all seek perfection in everything that we do. I mean, we try to do the best we can do. There's too many variables. When you get into 130.5 and you're doing an incident energy analysis, we tell you in 70E that it is an estimation. That's all it is. It's an estimation. When you go in to 130.7 C15C, we tell you that you're going to estimate the available fault current. You're going to estimate the clearing time. And when you're doing that, it's relatively easy for us to estimate available fault current. We can go to the next transformer upstream. There are calculators, Tom, like the one that you have, and we can assume an infinite primary on the transformer, and we get a number. We get a maximum number. When we've got a room full of electrical contractors, you know, we ask them to raise their hands. How many of you would agree that over 98% of the justified energized work you do is below 1,000 volts, and they all raise their hands? Every one of them. And then we ask them, okay, out of that work, all right, how many of you would agree that 95% of the time, that work, and this is in electrical construction now. We're not in an industrial facility. It's a different world, right? But in electrical construction, we say, all right, out of that work, how many of you would agree that 95% of the time, that justified energized work occurs in a panel board or downstream of the panel board? And they all raise their hand. That is a reality for the electrical construction industry. So what type of device do they have upstream? They're molded case circuit breakers primarily. So they need to understand the characteristics, typical application of those molded case circuit breakers, typical clearing times, and it works. It works. But when you do an incident energy analysis and you come up with 7.5, and then you say we're going to put a guy in an 8, well, now he might be exposed at 10 because it's not a perfect science, and he's wearing 8. And another problem is that the engineer could come out with 8.2. And now he says, well, we'll put you in arc flash PPE category 3. Now you got a guy wearing a 25 cal suit, most likely, when he should really be wearing a 12, something like that, you know, shooting at 150% of the exposure. So there's significant reasons that you can't use an incident, the numbers from an incident energy analysis to jump into the tables. But you know what everybody wants? Everybody wants those numbers. They want that easy button. They want to be able to put 1, 2, 3, or 4. Yep. And that's typically driven by the owner. That's what the owner wants. Yep. The owner wants an easy button, and all right. It's just, you just can't do it.
All right, let's move on to the next question. Okay, next question. 120.2a requires PPE based upon the SRA and the AFRA until an ESWC is verified. How do we do that when a transformer secondary has incident energy levels that are higher than any PPE? How about let's answering the why don't we just figure out the acronyms first, Jim?
Yeah, well, I actually put the acronyms because I didn't think it would fit. So what this individual wrote was 120.2a requires personal protective equipment based upon the shock risk assessment and the arc flash risk assessment until an electrically safe work condition is verified. He's right. He's right. So his question is, I got this big transformer secondary that for some reason I got to get in, and it has an incredible incident energy level. It's 400 calories. There's no commercially made PPE. So what does he get people to wear when he verifies that he is in an absence of voltage situation? So if you change the next slide, what's interesting is this guy's question was, or this gal's question was identified and acted on by the committee in this most recent revision cycle, and we added an informational note that Tom has on the next slide to provide some guidance for anybody that runs into a situation like that. Now, keep in mind, it's an informational note. And it basically says where your exposure is greater than the arc rating of commercially available ARC-rated PPE. Then, for the purpose of testing for the absence of voltage, the following examples of risk reduction methods could be used to reduce the likelihood of occurrence of an arcing event or the severity of exposure. And keep in mind, all right, it's risk reduction methods. We have hazards. You can't reduce the hazard. You can only reduce the associated risk. So if an individual had a situation like that, they could use a non-contact proximity tester, and they could use it on a pole. So you could get a 12, 15-foot pole, put a non-contact proximity test instrument. You're using distance as a tool, and you're isolating yourself. Or in number one, there you could have permanently mounted test equipment, and we actually permit that now in 120.5. The second option is where the equipment allows us to see a visible gap. So, for example, if we can see the blades of a disconnect open, increasing the worker distance. Remember, when you cut the distance in half, I've got exposed energized conductors and circuit parts. If I cut the distance in half, I increase my exposure by 400%. If I double the distance, it goes down to 25%. Right. So factor of 4. But the big one here, Tom, the one that I like the best, is to consider system design options when you're building that system to reduce the incident energy level. You want to comment on that?
Yeah, in fact, I have a slide later on about that as well. I'm not sure if it's a part of this one. Yeah, I think it's a part of one of the later ones. I'm gonna just go and I'm gonna go ahead here real quick. This, when you look, and we talked about this from a transformer perspective, that secondary panel board off of a transformer being one that's got a lot of incident energy. Like in this case here, I got a 250 kVA transformer, and my incident energy is 23.5 calories per centimeter squared. I could redesign that system, move that circuit breaker out. Now I can take credit for that main overcurrent device because it's now in a separate enclosure. I don't have to worry about line side propagation. The incident energy and that piece of equipment that I would get into probably a lot more frequently than anything else, I'm now reduced that down to 0.34 calories. And then what we did was we took that secondary breaker and we put that into the transformer directly. And that reduces the incident energy because now you're taking credit for that secondary overcurrent protected device. We have things like the arc reduction maintenance switch, where you can turn that on when you're doing energized or if you're doing justified energized work, and you need to reduce that level of exposure to the electrical worker. You can do that with these types of technologies. So there's a lot of ways to do that, but I know we also talked about the that VeriSafe absence of voltage tester that's out there, and when you take products like these and you combine that, it's like a layers of the onion, where you can turn something off and you still have to verify that you've done that, and you have to do that process of establishing electrically safe work condition. Things like this, and things like the arc reduction maintenance switches, things like taking the main out of out of that panel board, putting it in a separate enclosure so that you can de-energize and establish that electrically safe working condition, where you open that enclosure and there's absolutely nothing energized inside. Those are all steps that only can be taken before you get out there and you're actually installing anything. So that's got to be a part of the design phase, in my opinion.
Absolutely.
All right, let's hit the next question.
Yeah, we got 5 minutes.
Yeah, regarding establishing an electrically safe work condition for 120.5, what is the justification for the exception permitting permanently mounted test devices to verify the absence of voltage? Are these devices expected to be exceptionally reliable? When I read through the rest of the information this submitter put in, doesn't sound like he was too happy. It doesn't sound like they trust those things like the product that we just showed, that absence of voltage verification. And this individual made a comment about still testing with a test instrument for absence of voltage. In addition to, even though his comment was, even though I have that presence of voltage indicator, I'm still going to use this meter. and that would be a good thing, right? You would still want to be able to, you would still do that, and although in some cases you may not have to because of the technology, but it's always good to add that additional layer of the onion in there.
Absolutely. Well, one of the things that we need to do is as technical committee members, we cannot close our eyes to new technology. We have to look at it. We have to ask questions. We have to make sure that it's vetted. And this concept has been around for multiple cycles. I think it's been around for 4 cycles. And the committee said, no, no, no. And we told the proponents of this concept that you got to jump through hoops A, B, C. And they came back and they did it. Now you got to jump through D, E, and F, and G, H. They jumped through all of the hoops. And when you go to that exception, it's got to be permanently mounted and installed in accordance with the manufacturer's instructions. It has to test conductors at the point of work. It has to be listed and labeled for the purpose of verifying the absence of voltage, which is important. We have a lot of test instruments that are listed, okay, but they're listed to be safe, not necessarily to be accurate. And 3, it tests phase-to-phase, conductor circuit parts both phase-to-phase and phase-to-ground. And the test device is verified as operating satisfactorily on any known voltage source before and after. So it's got batteries in it for after. It uses the voltage source before. So, the committee agreed that, yes, they are reliable. I don't think that we could define exceptionally reliable, but the committee felt that that was a viable method to getting it done. Now, within your individual facility, if you just want to use that as an indication and continue to do point of contact testing with a portable test instrument, then I think that would be a fantastic way to go. But, as an indication, it would be, exceptional for us to know that there was an absence of voltage.
Okay. And let's see, it's 1:56. Let's try to see if I can get one more in here. Is there a specific one that you would want to cover?
I don't know. Whichever one, I can't see them. Whichever one you think we should jump into, let's jump into it.
All right. Let's just go to the next one then. Do this next, the next question. Can a review be conducted of SKM Arc Flash module or any unique modeling or settings which affect results? So, in my opinion, from an SKM, from a power systems analysis software, and this one, this question called out SKM, and I'm sure that other software applications have the same capabilities. But in SKM, we can run scenarios. There's a thing called Scenario Manager, where you can turn motors on and off, reconfigure the power distribution system, like pop out that main out of the panel board and put it ahead of the panel board instead of within that panel board, or can you put a fusible disconnect switch in front of something and help you reduce the incident energy and create a lower that impact for the electrical worker. You can run these different scenarios that can give you a picture of a design change or a system change. If I turn a lot of motors off, I can lower fault contribution to a point where I'm in a longer time region clearing time, and that could create a higher incident energy than if I had all my motors on. And it's good to be aware of that. You may be able to change some of your settings, like if you look at this device here, where you have a trip curve with an electronic trip unit on it, and you could possibly move this or this short time delay up and down. It may be you may have it set, unfortunately, up here for no apparent reason, and if you can lower that set point, you can possibly lower your incident energy in your facility. So I think you're left to the skills of the engineers and use of the tools to be able to run that analysis, run those what-if scenarios to see where are your vulnerabilities, where are those areas in your power distribution system. There was a IEEE paper that was delivered in the electrical safety workshop that looked at how, like when you talk about maintenance and you talk about your power distribution system health, etc., how do you know where to start next? Do you just reset cycle all your breakers and just start from A to B, from the left side of the plant and move to the right side of the plant and then schedule all those? Or should you understand where your vulnerabilities are and focus on those areas first, and then focus your maintenance efforts in other areas second? Stage your efforts around maintenance based upon your awareness of your power distribution systems vulnerable areas in the distribution system. So I would say there's a lot of different ways to be able to analyze your scope of things there. All right, so it is. See what I'm at 2:01. I know some of these guys get a little nervous, so what I'm going to do is I'm going to show the exit Menti code. So this is the sign out sheet. I showed the sign in sheet before. This is the sign out sheet. That'll give you, it's 28, 93, 88. That will have that. You go out there, sign out, so you hopefully will signed in, you'll sign out, and then I'll use that to prepare the PDH professional development hours. So Jim, that ends, I think, our program. We did our 2 hours. And I want to thank you personally for dialing in. I know you were a wealth of knowledge, and we shared a lot of information. Didn't get through all of our questions, which I didn't think we were going to, but we had a great discussion. Hopefully, everybody got something out of it. So thank you very much.
Yeah. Thanks, Tom, and thanks everybody for listening in.
Yeah, thanks for everybody for listening in. I appreciate all of the chats, and what I typically do, Jim, is I take some time to dial everything down. So if you wanted to poke through, if you have any of the chat sessions on WebEx that you wanna hit, we can always do some flybys and try to answer some things. But other than that,
there's a question about arc blast. It was described as a shockwave concussive concern, and there always is. There is an arc blast in every arc flash incident, but the amount of energy, the amount of concussive forces is really a function of the available fault current and not the time. So where you're in very high energy systems, you're going to see a significant arc blast. When you're in those very high energy systems, that's where we can see doors ruptured and in some cases blown open.
Yeah. Yeah, that is absolutely true. I'm just going to take a look through at some of these. Let me look on YouTube. Some of the questions out there. Everybody's saying thanks. Ryan Jackson said that he stuck in here to the end. Oscar Serrera, thank you very much. Gustavo, thank you. Tim Krauscher was on as well. Thanks, Tim, for joining us. We had Jason Moore. Yeah, I think we got all the questions on YouTube. Just looking back through time just to make sure we did all that. We could probably do another session to finish all of those other questions,
We could, we'll give them some time. I think that was a lot in 2 hours.
Oh, yeah. And this will be available on YouTube, so they'll be able to download that, watch it later, and it'll probably be on my Facebook site as well. So, all right, so I'm going to shut down the streams. I'm going to first stop sharing here on WebEx. I'm going to hit that stop sharing. And thanks, everybody, for joining us. Appreciate filing in. I'm going to save off these chats. I usually save the chat from YouTube and from WebEx. So 70E Q&A chat, save. All right. Well, I'm going to shut down the things. Thanks again, Jim. I appreciate. I think this was a great session, and we'll definitely be talking some more. So.
All right, man.
All right, brother. I'm gonna shut down the WebEx. Okay.
All right. Bye-bye.
All right. We'll see you. Bye. Okay. So my tubers are still out there, and my still got about 100 people on YouTube, and I'm not sure how many people on Facebook. So thanks for everybody for dialing in. Jim was Jim was doing good, so we're gonna look for a part two. I agree with that. So we're gonna do everything I can to try to get Lasso, Jim, and maybe a few others. Once I get that video, I wish I had his video. I'm not sure what happened. I know I lost him. I think he was probably wireless on his side. I'm not sure, but so I appreciate everybody hanging in there, and we will hopefully catch you next time. So for right now, for my tubers and everything out there, I'm going to end up doing my outro, and we're going to play the outro. So thank you, and take care. All right.